Good day, everyone. Today I will be tackling about the power rule. So let's get to know what is the power rule. So in calculus, the power rule is used to differentiate func- functions of the form f(x) is equal to x to the power of r. So whenever r is the real number, since difference differentiation is a linear operation on the space of differentiable functions. So polynomials can also be differentiated using this rule, and the power rule for the exponents am n is equal to am2 times n. To raise a number with an exponent to a power, multiply the exponent times the power. So the power rule in calculus also is a fairly simple rule that helps you find the derivative of a variable raised to a power, such as x to the power of 5 to 2x to the power of 8, 3x to the power of negative 3, or 5x to the power of 1 half. So all you do is to take the exponent, multiply it by the coefficient. So the coefficient is the number in front of the x, and decrease the exponent by 1. So ang exponent minusan siya og 1. Let's have. So the power rule also is the one of the most commonly used derivative rules. Say the derivation of x to the power of n is nx to the power of n minus 1. So it is the derivative. So let's have an example. So what is the derivative of x to the power of x2? So for x2, we use the power rule with n is equal to 2. So the derivative of x2 is 2x times 2 minus 1, then 2 times 2x, 2x1 is equal to 2x. And the derivative of x2 is 2x. Let's have another example. So what is d over dx times 1 over x? So 1 over x is also called as x to the power of negative 1. Using the power rule with n is equal to 1, d over dx times x to the power of n is equal to nx to the power of n minus 1. So d over dx times x to the power of negative 1 is equal to negative 1x to the power of negative 1. Negative 1 is equal to negative x to the power of negative 2, because we come up with negative 2 because negative 1 minus negative 1 is equal to negative 2. So using the mark, we can write the power rule like this: f times x to the power of n is equal to nx to the power of n minus 1. For example, let's use this mark. What is the derivative of x3? So f times x3 is equal to 3 times 3x 3 minus 1. So we come up with the answer 3x2. So how to remember? Multiply the power, then reduce power by 1. So this is a short table where it is the power rule with some sample values, seeing the pattern. So f times xn is equal to nx times n minus 1. So f to the f. So that's for the f, and let's proceed to the x. So in the x, 1 times 1, 1x times 1 minus 1 is equal to x0 is, and x0 is equal to, and x2, so 2x times 2 minus 1 is equal to 2x1. That 2x1 is equal to 2x. x3, 3x times 3 minus 1 is equal to 3x2. So 3x2 is equal to 3x2, because let's proceed to x4. 4x times 4 minus 1 is equal to 4x3. So it is equal to 4x3, and so on. And for the negative exponents, let's have x minus 1. So negative x minus negative 1, negative 1 is equal to negative x is negative 2. So it is equal to negative x to negative 2, because negative 1 and negative 1 is negative 2. And x, let's proceed to x2. So x2, negative 2x times negative 2 minus negative 1 is equal to negative 2x negative 3. So negative 2 minus negative 1 is negative 3. So x minus 3, negative 3 times negative 3 minus 1 is equal to negative 3 minus 4. So negative 3 minus negative 1 is equal to negative 4, and so on. And that's all for the power rule. Hope you have something to learn. You have lesson that you've learned from our topic, the power rule.